Today we will see how photovoltaic cells can be made from simple DVDs. To start making our solar panel, we will use two doors like this as the structure. But first, we must make the surface completely smooth. To do this, we will begin by removing the handles or knobs, the locks, and we will also remove the hinges. Now, we do the same with the other door. Next, we prepare some round pieces of wood to cover the lock holes. We sand them to fit tightly into the holes. We glue them with cyanoacrylate, like this. I have to scrape the imperfections from the door to apply putty so it adheres perfectly to the wood. We start applying wood putty to all the holes and imperfections on the doors to have a flat surface that will serve as the structure for our CD solar panel. After 24 hours, when the putty is completely dry, we sand the entire surface of the doors to make it very smooth and ready for painting. We start painting one side of the doors with zinc paint. And now we continue painting the other side of the doors with black synthetic paint. They look great after painting. We continue by joining the two doors with some hinges. we join the hinges like this. And now we fix the middle hinge. This hinge has been modified by joining the two parts with a long pin. This way the doors cannot accidentally separate. There is a 25mm or 1-inch gap between the two doors. This way we will have enough space in the middle to build our solar panel. We are going to make a solar panel with CDS, but we will not use just any CD, but these purple CDS because they have an internal silicon layer. This type of CD does not contain silicon. It is not useful. We need silicon CDS. These ones are useful. To make electrical contact on the back, we will carefully remove the plastic with the grinder to reach the back silicon layer. This way we can make electrical contact. We are going to need an enormous amount of silicon CDs. It will not be easy to find them. In total, we will use 210 CDs, which will equal 327 volts. We remove part of the plastic to reach the back silicon layer. This way it conducts electricity. Now we will cut strips of aluminum foil that we will use later to electrically connect the CDs. With 30mm wide, it will be enough. We must fold all the aluminum strips in half, like this. Now we cut all the aluminum strips into 45mm pieces to make the electrical connections. Here we have a CD with the back silicon exposed. We take an aluminum strip and put it here on the back of the CD and tape it. It should look like this way. And we do the same with all the CDs. Now we are going to measure the voltage generated by one of our silicon CDs. We are in front of a large window where a lot of sunlight enters. We check the voltage, and we have 1.56 volts. We measure again. 1.56 volts. Very good. At this point, we must start placing our photovoltaic cells. We will follow the pattern we have on this plan. We will connect all our CDs in series this way to get 330 volts of direct current and a maximum power of 3000 watts. Thanks to the three-dimensional double silicon layer, a DVD is able to generate up to 6 times more energy than a normal silicon cell of the same dimensions. We must wear latex gloves to avoid accidental electrical contacts. And we start positioning the CDs according to the electrical diagram, like this. If you look closely, the aluminum electrode taped on the bottom of the CD should make contact with the top layer of the next CD, and so on. This way we will connect all the CDs in series to add up the voltage generated by each one. And we do the same on the other part. Now that we have correctly positioned our photovoltaic cells, we must glue them to the wooden base with hot glue so they do not move. This way, they are very well glued. As you can see, the aluminum electrodes do not make good contact with the top silicon layer of the CDs. We do not want to tape them because the solar panel would be less efficient, so we will solve it in a more ingenious way. Now we mark where we need to drill. And we make two 10mm diameter holes, like this. Now we put this strip of aluminum foil here and tape it. This will be the positive terminal, and this the negative terminal. We do the same on the other part. Now we pass the ends of the wires through the holes we made. We fix each wire with a screw to the solar panel's electrical terminals. The black wire will be the negative, and the red wire will be the positive. We repeat the process on the other half of our solar panel. And we seal the holes with silicone, like this. To make good contact with each aluminum electrical terminal, we will stick an adhesive silicone drop on each one of them. Like this, we will put one on each strip. Later, we will put a synthetic glass sheet on top that will press the aluminum strips against the CDS, making good electrical contact. Now we place the synthetic glass panels in their place. And we remove the protective film. Once the protective film is removed, we can seal all the edges of the synthetic glass with transparent silicone. Additionally, this way they will be well glued. Now we are going to put the MC4 connectors, which are special for solar panels. Here we have put another type of connector to avoid mistakes. This way we connect the two halves of our solar panel in series. Now we are going to screw these aluminum profiles around our solar panel. This way it will be much more robust and have a better finish. They also help to better hold the synthetic glass panels. The result is impressive. We have also made this safety lock. We are going to screw it here. This way we can transport it without the risk of it opening. And now our panel is finally ready. We will use this wooden base to fix the electrical elements. This device is a solar frequency inverter. It transforms the current generated by the solar panels from 200 to 400 volts DC to 220 volts AC, like household outlets. The purchase link is in the video. This is a 20 amp circuit breaker for direct current. It will be used to power the solar inverter. And finally, a socket base. Let's mount it. These cables will go from the output of the circuit breaker to the input of the inverter. The red cable will be connected to the positive terminal of the inverter and the black cable to the negative. Like this. These are the power cables to connect the solar panels, the positive to the positive part of the circuit breaker and the negative to the negative part. Now we cut the power strip cable here. We strip the cables, put on these electrical terminals, and connect them to the AC output of the frequency inverter. The ground cable will be connected here. Our electrical panel is now finished. Now we are going to test it indoors with the light from our spotlights and the sunlight from a large window. We connect these two cables like this to connect the two panels in series. And now we will connect the solar panel to our electrical panel. Let's check the direct current voltage generated by our large solar panel. (317, 318 volts. When activating the circuit breaker and powering the inverter, there is a slight voltage drop, 290 volts. The inverter is programmed to deliver 220 volts at 50 Hz. We turn it on, and we see that the power strip is energized. Let's check if this light bulb turns on. Very good. For now, the circuit seems to work correctly. It's time for the real test. Outdoors. Today is a very sunny day. It's ideal weather to test the power of our solar panel. We position it at about a 30 degrees angle for better sun exposure. Now let's connect the electrical panel to the solar panel. We connect each cable where it belongs. Let's do the first test with a small air compressor. We switch on the circuit breaker and power the frequency converter. We turn it on by pressing the green power button and connect two energy meters to check the power consumption of each device. The frequency converter display seems to flicker, but it's an effect caused by the camera we are using to record the video. The display shows 50.00 Hz, which is the frequency of the electrical current it provides. We connect the air compressor. Its consumption is approximately 700 watts. And it works perfectly. This is normal due to the high power generated by this panel and the good weather. We can see that its actual consumption is 727 watts. We turn off the compressor and check that the consumption is 0 watts. Let's connect something much more powerful to see what happens. Now the day is a bit cloudier, but let's trust in the efficiency of our solar panel. Let's start up this inverter welding machine. We plug it in. We also brought an angle grinder. We see that it works without problems, even with the slightly cloudy sky. It consumes 865 watts of power. And now let's weld. We turn on the welding machine. Adjust the power. And start welding these two iron profiles. We are amazed to see the efficiency of this solar panel since, due to the power adjustment we made to the welding machine, the consumption was the maximum that the solar frequency converter could provide, 2200 watts. With this invention, we can work easily in the field. If you've made it this far, share your thoughts in the comments and give us a like. Your likes and comments support us a lot. Let's continue with our outdoor work session. We can see that this 750-watt drill also works without problems. Now let's start up this 2200-watt demolition hammer. The panel can even handle the demolition hammer. Spectacular. As you can see, we can work with all kinds of tools in the field. Now let's water with this water pump. The panel also handles the pump without problems. We are drawing water from this pond at about 15 meters. After a long day of work, it's time for a well-deserved rest. This 30-watt fan will provide us with a cool breeze. Comment if you also sleep after working. Tonight we will test our solar panel again, by the light of the full moon. What will happen? you will see in our next video. Thanks for watching. If you want to support us and our videos, please consider becoming a member. You will have also access to other advantages for members.